Welcome back, everybody. Welcome back to my YouTube channel. Make sure you hit the subscribe button. Comment on any videos you like. Usually that gets a laugh, but I guess it is still 8:39 in the morning. You guys still asleep?
Yeah.
Yeah. All right. Identify the zeros and the axis of symmetry. The zeros of a function. Can somebody tell me in their own words what is a zero of a function? What's a zero of a function? Good. Any point where it crosses the x-axis, right? And for a quadratic, there's three options. I could have 1 0, 2 zeros, or none at all. How many zeros does this one have? 2. That was recorded, I guess. Yeah. So I see 2 zeros happening, right? Now, remember to write them as coordinates. It looks like I've got a -4, 0, and a 2, 0. Those are my 2 zeros. Now, where is my axis of symmetry? Where is my axis of symmetry? It's not -4.
-1.
-1, good. And remember that we should write it as x equals -1. That's my answer when I ask for the axis of symmetry, x equals. So when we go over our homework in a minute, if you had not written x equals for each one of these, please go ahead and write that back in. Number 2, find the axis of symmetry using the formula. Can somebody tell me what the formula is? X equals. Good. X equals -b over 2 times a. I need you to start memorizing that if you have not already done so. -b over 2a. -b over 2 times a. -b over 2 times a. Let me do this. Hey, Taylor, what's my axis of symmetry formula? X equals. Hey, what's the axis of symmetry formula?
-b over 2a.
-b over 2a. What's it, Taylor? Tyler, what's the axis of symmetry formula? Ben, not here.
Elena's got it.
Sure, I'm back. What's the axis of symmetry formula? Good. David Haas. No. Joey, what's the axis of symmetry formula? Good. John, what's the axis of symmetry formula?
-b over 2a.
Good. One more. Elena, what's the axis of symmetry formula?
You really empty your thing.
No, that's so possible. How's it going, Mr. Bob?
I want to check in and say hi.
Hey. You having a good day?
So far, yeah. 3
Okay.
days in a row. I went to bed before 9 p.m.
Wow.
I feel like alert.
Yeah.
No, I'm not operating at like top rating. Yeah, I'll get there.
That's good. That's good.
Have a great day, everyone.
The Martian was on last night, so I had to watch that.
Great movie.
I love that movie.
Whole movie I watched it thinking that eventually like aliens were gonna like take over.
No, nothing like that. All right, so it's x equals -b over 2a, right? X equals -b over 2a. Please don't forget about the x equals, because remember, I'm looking for the axis of symmetry. -b over 2a. All right, so what is a and what is b in this case? Somebody raise your hand and tell me, what's a and what's b? Will?
A would be 2.
And b is? 1. Good. So we have x equals -b over 2 times a, right? -b over 2 times a. Oh, why did I write -20? Whoops. -b over 2 times a. So that gives me a -20 over 4, which is x equals -5. There's my axis of symmetry. If you just wrote -5, I would take off a point, probably like a half point. It's x equals. Why am I so picky about that? Because again, it's a vertical line at -5. All right, let's go over the homework. Okay, I'm going to have you guys give me some answers here. Can somebody tell me why is a zero of a function the same as the x-intercept of a function? Why is it the same?
Because the zeros at the x-intercept.
Good, because the zeros are the x-intercepts. And if I plug in 0 into the function, that gives me the y value, right? That gives me the y value of the intercept. Liam, where is the axis of symmetry of a parabola located? Yeah, this is number 2. Yeah, where is the axis of symmetry located? In the center of the graph, center line, basically, the center line. Hayden Tripp, tell me the 0 for number 3.
Is it 1, 1, 0?
You're close. Not positive 1, but
Oh, negative 1.
negative 1, comma 0.
I think that is a negative 1. I just struggled with it.
Oh, I see. And find the zeros. Okay, that's it. We don't need to identify axis symmetry. Oh, forgot about serenity. Serenity, number 4 there. Give me the 2 zeros that you see. Good. Negative 3, 0, and 3, 0. Good. Berkeley, number 5.
Is it negative 0.5?
This one here.
Oh, there isn't one.
There isn't any. Good. There isn't any zeros. Good. Number 6. Number 6. Carson, where would the axis symmetry be for number 6?
X equals negative 1.5.
Good. It looks like x equals negative 1.5. Rosalie, number 7. X equals what?
I did that wrong.
Well, where is it? It's up on the screen here, number 7. X equals, where's the center line? X equals 2. Good. And number 8 here, Mr. Rudder. Where's the axis symmetry? What's that? X equals negative. I thought you said the x equals. I just didn't hear it, right? Good. Okay, now these 4, 9, 10, 11, and 12. These are the ones where you had to use the formula. Okay? So, Hannah, what did you get for number 9? Good. X equals negative 2, right? X equals negative 2. Mason, what did you get for number 10? X equals 3. Good. Number 11, Will, what did you get for 11? Uh-oh. That's an issue. Will, what's the axis symmetry formula? X equals what? Good. What's my A value? What's my B value? So X equals negative 3 over 2 times 2. So negative 3. Oh, look, I just did it for you. X equals negative 3/4. Look at that. Oh, I just kind of crossed out my 4. And number 12. Mackenzie, what'd you get for number 12? X equals what?
Negative 1/6.
Negative 1/6. Let me just make sure it comes out negative. X equals negative B over 2A. It should come out positive.
Okay.
Because this is negative 1 over negative 6, and those will cancel. Does that make sense?
Yeah.
Any questions from the homework? How we do? Yeah, Rosie? Because it was negative B, so negative 18 divided by 2 times 3. So it's 18 divided by 6, basically. That make sense? Okay. All right, so I'm glad we felt like the homework last night was not too difficult, because we will be using, especially those last 4, we will be using that formula today in class. Welcome. Let's go. No, section 9. Section 9. Yeah, 9A. All right, so in this section, we've talked about zeros. We've talked about axis of symmetry, right? We've identified zeros given a graph. We've identified axis of symmetry given a graph. Okay? We have identified the vertex given a graph. We actually did that back in section 9.1. We've identified the axis of symmetry given the equation. We have not identified the zeros given an equation, because that's a little bit more work. That will come later on in this chapter. So what we're going to do today is finding the vertex given an equation. Once you've found the axis of symmetry, you can use that to identify the vertex. Now, look at the phrasing here. Once you have found the axis of symmetry, that implies that you have to find the axis of symmetry first if you want to find the vertex. Do we all know where a vertex occurs? Remember, the vertex is at that minimum or maximum point, right? The high or low point. A very important piece of the graph. We've been able to find the axis of symmetry, the center line, but we don't know where up that, well, I guess we could tell up or down, but we don't know where the vertex is on that line. Now, if we're able to tell where the vertex is, we can kind of start putting things together. So, first thing, step one is to find the x-coordinate of the vertex, find the axis of symmetry by using the zeros or the formula. We're most often going to be using the formula, okay? And what is the formula? Again, that's x equals negative b over 2a. To find the y-coordinate, you substitute the x-coordinate of the vertex into the function. Because we know, I reinforced it yesterday, the x-coordinate of the vertex is the axis of symmetry. The vertex has to lie on the axis of symmetry. So that means x equals that number. That's why I've been saying so long, x equals, x equals, x equals. That x-coordinate is the x-coordinate of the vertex. So step two is basically just take that x-coordinate, plug it into the equation to see where it comes out, and then the last step is to write it as an ordered pair. So let's try it. This is our first equation here. I gave you the graph along with it so that we could kind of verify where it is in the end. Step one, find the axis of symmetry. Okay, step one. So we've got x equals negative b over 2a. Right, to find the vertex, you need to first find the axis of symmetry. My a value is 0.25. My b value is 2. So that means my axis of symmetry is x equals negative 2 over 2 times 0.25. Well, 2 times 0.25 is 0.5. So this is negative 2 over 0.5. Let's see what that is. Negative 2 divided by 0.5. Come on now. Negative 2 divided by 0.5. Come on now. Negative 2 divided by, there it goes, 0.5. Negative 4. X equals negative 4. I gave you the graph. Did we confirm the fact that it's negative 4? Let's take a look. Negative 1, negative 2, negative 3, negative 4. Is negative 4 my center line of my graph? Yeah. And I know my vertex has to lie on that center line. So where is my vertex then? Well, it's negative 4 comma something, right? This is going to be my answer. Negative 4 comma something. To get that something, all you need to do is plug it back into the original equation. You need to go y is equal to 0.25 times negative 4 squared plus 2 times negative 4 plus 3. Does everybody see what I'm doing there? Was that Chewbacca? You just plug negative 4 back into the equation. Go back to the original, plug it back in. So let's test it out. 0.25 times negative 4 squared. Whoa, use parentheses, Mr. Lavin. Use parentheses. Plus 2 times negative 4. What the heck is going on with my calculator? Notice I blame it on the calculator. And then a plus 3. Right? See, all I'm doing there is just plugging in negative 4 into that equation. I get negative 1. And that's my answer. Can we confirm the fact that it actually is at negative 1? Let's take a look. Negative 1, negative 2, negative 3, negative 4, negative 1. Yeah, that is where my vertex ended up. Okay? Questions about that? Now, we're not always going to have the graph. Okay, I just put that there so that you could see what happens. So let's try to do it without it now. Negative 3x squared plus 6x minus 7. Negative 3x squared plus 6x minus 7. What's the first thing that I've got to do?
Right, your formula.
Right at your formula, okay. Find the axis of symmetry, right? X equals negative b over 2a. So let me pull some names here. What is my a value in this case, Kyler? Good. What's my b value? Good. So that means it's x equals negative, and then we've got 6 over, my b's and my 6's look way too similar. 6 over 2 times negative 3. So that gives me negative 6 over negative 6. Do you notice how those negatives will cancel? So that equals just 1. X equals 1 is my axis of symmetry. So you have to find your axis of symmetry. Every time I ask you to find a vertex, you're doing 2 problems in one. Because I've got to figure out where that y value is now. All right, well, to do that, I'm just going to plug in 1 into the equation. Oops, that's a minus 7 at the end. So let's go ahead and do that in our calculators. We got negative 3 times 1 squared plus 6 times 1 minus 7, negative 4, which that's the y value of my vertex. See, what did I do there? I really just identified 2 very important pieces of the function. I know the center line of the graph is at 1. I go right 1 and I make my dotted line. And now I know on that center line that I can take 1 comma negative 4, and that's my vertex. What else do I know? What about the 3 being negative? What does that tell me if the 3 is negative? It's a frowny face, right? It goes downward. So I know a lot, and that's what we're going to be doing within the next couple sections, putting it all together. We know where the axis of symmetry is. We know where the vertex is. We know whether it opens upward or downward. We can use all of that to start graphing our functions. Do you have a question?
Yeah, so we don't put x equals in front of the...
It all depends on what I ask. See, I ask you to find the vertex, and the vertex is a coordinate. If I said find the axis of symmetry, that's when you write the x equals.
But would you still have the negative 4 if you're going to find the symmetry, or would it just be a single number?
Just a single number if it's the axis of symmetry. Yeah. Let's take a look at our last one for this set. X squared minus 4x minus 10. So again, we've got, well, what's, Travis, what's my formula? Good. And geez, I picked Nevaeh and Ben. Look at that. Crazy. Carson, what's my A and my B value?
Your A value is x,
Oh,
2, 1x,
1.
1.
And my B value is?
B value is negative 4.
Good. So x is equal to negative 4 over 2 times 1. All right, negative 4 over 2. Those negatives will cancel, leaving just a 4 over 2, or in other words, x equals 2. So if I were graphing this, I know that the center line of the graph would be at 2, positive 2. And I can make my dotted line at 2 on the right. But that's not what I asked. Here, all I asked you to do is find the vertex. So it's at 2 comma something. Let's figure out what that something is. We plug that 2 back into our original equation. All right, so we've got 2 squared minus 4 times 2 minus 10. Negative 14. And that's my answer. Questions about that? Okay, one last word problem that we got today. The graph of f of x is equal to negative 0.06x squared plus 0.6x plus 10.26 can be used to model the height in meters of an arch support of a bridge. See, what you guys don't understand yet is that quadratics can model a lot of real-life situations. Quadratics can model the shapes of any curve. It can model anything thrown. Like if you throw anything, like if I throw this marker, watch here, everybody watch here. Watch the shape of this marker. You see how it went up and then back down? Right, because of gravity, because the acceleration due to gravity is constantly pulling back on it, the shape is a parabola, right? So we can model that using a quadratic function. I think we talked about like stopping distance earlier in the year, right? Like if a light turns yellow, light turns red, you got to use that stopping, you can write the stopping distance as a quadratic. Think about it this way. This is modeling the height of an arch support for a bridge. So what it's really saying here is that I've got like, so two sides, maybe there's some water down below here, right? And then I've got this bridge. And there's some sort of arch support. What does that look like? That's a parabola, right? That's a quadratic. So it's saying that is modeled by this equation, the negative 0.06 x squared plus 0.6 plus 10.26. Does it make sense? Look, negative a value facing downward, right? So do we see it there? Yeah, okay. So what this is saying is now we got this bridge. The arch support is this equation, okay? How did we come up with that? We don't know. That's more advanced things that you could get into later. Okay, my calculus students do things like that. Like they figure out what that actual equation is based on other information. So I know that where x-axis is the water level, y distance is horizontal. Can a sailboat that is 14 meters pass under the bridge? So I've got this sailboat coming along. Here we go. Here's my sailboat. Say the water's down here, right? It's coming here. It's the river flowing up. I'm getting really artistic here. And I got this sailboat coming through. Right. It's 14 meters tall. Will it fit underneath the bridge? What point am I really going to try to find of this parabola? The maximum, the top. What coordinate is that? What's another name for that? Well, I'm going to need to use that. No. The vertex. The vertex. I need to find this coordinate because the y value of that coordinate will tell me how tall that bridge really is. And then I can tell, will that 14 meter tall ship pass through? So let's find the vertex. Doing that, we need the axis of symmetry, negative b over 2a. A is negative 0.06, b is 0.6. See, when it models real life stuff, the numbers get kind of messy, because real life is messy. Negative 0.6 divided by 2 times negative 0.06. All right, let's plug this in. I've got negative 0.6 divided by, and I'm going to put this in parentheses, 2 times negative 0.06. I'm going to get, oh, that's not messy at all. 5. What was I thinking? 5.
I don't think it works.
Well, that's the x value.
Oh, yeah, you're right.
The y value is the height. So let's figure out, let's plug that in. So negative 0.06 times 5 squared plus 0.6 times 5 plus 10.26. Let's figure out where that ends up. Negative 0.06 times 5 squared. Didn't hit the negative. Negative 0.06 times 5 squared plus 0.6 times 5 plus 10.26. 11.76. So I know the vertex is at 5, 11.76. Will the 14 meter tall boat fit through?
Yes.
No. Well, because this is only at 11.76 meters. And this is 14 meters. Uh-oh. Take the flag off the top. So this is not going to fit through. Not gonna fit. Not gonna fit.
Gotta do it.
Not gonna do it. Not gonna do it. All right. Questions there? No? Okay, perfect. I'm giving you guys 13 minutes to work on your homework. So long, everybody at home. Later.